Good day. You can see this is called Calculations Troubleshooting. I'm hoping I put it in the package. About half the test, maybe less than half, is on the math of solutions, and this is important A for the test, and it's also important if you're going on to Chemistry 12. This stuff, you're assumed to know this automatically. It starts out fairly easily and gets a little more complicated as we go on, but generally students find the math part of the solutions test to be more straightforward than the qualitative part. So back to chapter 4, if I give you a mass, you should be able to figure out the concentration of a solution for a particular compound and if it dissociates for its ions. Number 2 is really easy. It's the old dilution stock solution calculations. We have the C1V1 equals C2V2. And so what that means is, so we know C times V is moles, so moles are conserved. So let's say we're starting with a stock solution, and so we'd have a small volume of a high concentration, and we up the volume, our concentration is going to go down. Concentration and volume of solution are inversely related. So you have to know how to rearrange these equations and solve them, and it's pretty easy. So if I want C2, it'd be C1V1 divided by V2. If I wanted V2, it'd be C1V1 divided by C2. Fairly straightforward. So I don't think those would be a big issue. Number 3, this is talking about dissociation with no mixing. You write the dissociation equation, and then you use stoichiometry, and that means the coefficients to figure the concentration of each ion after the dissociation. So back here it talks about, hey, questions 1 and 2 on the sample notes. The C1V1 ties into that. Question 3 on the sample notes was find the concentration of ions. Question 4 is all about being organized. It takes up space to do these things. So now we're mixing two solutions that are soluble. That means they generate ions. And it also involves dilution because you've mixed two solutions, you get a larger total volume. So it means you write the dissociation equation for each solution beforehand, and you figure out how many moles you have present based on coefficient. Then once you've done that, you simply divide the moles of each ion by the total volume. If you had any common ions, or for example, if you get chloride from one compound, chloride for another, you add them up and then divide by the total volume. And that will give you the concentration. And the concentration has to be in moles per liter. Number 5 is a close cousin of number 4. The only difference is we have a reaction this time until you go through the same steps. But this time to get the mass of precipitate, you have to find out the moles of limiting ions, in this case for forming the precipitate, and then it's regular stoich to get the mass of the precipitate. For concentration of spectator ions, it's the exact same as what you did here in question number 4. So that's not giving you very many details. It means if you don't know what you're doing, go back to the notes on calculations. There are a bunch of notes. Go through, look again, and it shows you the examples that illustrate the steps that you will follow so you can dominate this part of the test.